One of the useful features of the ReplicaNet networking library is that we can ask it to start recording and also play back recorded network sessions. To start recording is very easy. All we have to do is implement the callback session record function, part of the ReplicaNet class definition itself, and we can choose what we want to do and where we want to send the data. So in this example, what we do is that we regularly flush the data to just an output file using a very simple writer class, which is here. And this writer class is like a chunked or buffered chunked writer class, which also does underlying compression of the data, just to make the file a little bit smaller when we are recording. And this kind of recording can be started during any network session in the example code by pressing the R key, and it automatically starts writing out to a record.repnet file. What we can then do is that we can tell ReplicaNet that we want to start processing recorded information, and that is done by implementing the callback session playback function, which asks us to send ReplicaNet the next compressed data packet that it asked us to save previously, which is what this quite large function does, because it decompresses different chunks. So if I ask it to play back a pre-recorded session, I can just do this. Now, in this session, the player will fly around. I can use the keys that are mentioned here, 1 through to 5 and 0 and also 9. If I press 0, it pauses the playback by setting the speed to 0. I can also play it back at 10% normal speed, and you can see that all of the objects, all of the movement and everything else, all of the network time advances at 10% normal time, 0.1 floating point value. If I press 2, it plays back at half speed. Press 3, it plays back at normal speed. Press 4, 1.5 times, and then 5, 2 times normal speed, and so on and so forth. If I start playing it back at normal speed, I can press the 9 key to advance the network session 10 seconds into the future. And we can see here that it keeps on jumping every time I press the 9 key. I can also do this when the network session is being played back at a very slow rate, like 10%. I can jump forward 10 frames. And I can jump forward another 10 frames. And you can see here that the projectiles are updating at the normal expected quite slow rate. Playback at normal speed, there we go. So this is a very useful feature of the ReplicaNet networking library, because you can also use this to record and then play back self-running game demonstrations, or just like a recorded playback of a racing game or a sports game or something like that. The recorded data is just the data that would have been sent over the network. If there's only one player active in the game, then what it does is that it uses a fake observer session to capture some of the underlying network packets and then write those to a file. So using this method is actually a very powerful way of implementing instant playback or demo playback of games which have been integrated with a network session. And as you can see here, it's reached the end of the data. Now, we know that it's reached the end of the data, so there's a session error, as there is no defined master now. However, because we've chosen not to exit the application when there is a session error, the underlying objects are still updating their replicated positions using the last known good received data. Normally you wouldn't want to see this, but this is just an example that we can continue on the session using the last good known received data and then predict on what might have happened.